In this video, you'll understand why ChatGPT can write like Shakespeare, how your phone unlocks with your face, why deepfakes look so real, and which AI architecture Netflix uses to predict your next binge. Let's dive in. Ever had that friend who always guesses your food order before you even speak? Or that weird moment in school when you solved math problems the exact same way every time? Like your brain was running code. That's not coincidence. That's a neural network in human skin. Because here's the secret. AI isn't magic. It's mimicry. Neural networks aren't magical computers. They learn like we do, by watching, failing, and repeating until they get it right. But not all of them think the same way. Some memorize, some analyze, some even dream in pixels. So today, we're diving inside the mind of AI to meet the 6 types of neural networks that quietly run the modern world. From your Spotify discovering your next favorite song, to medical AIs saving lives. These are the brains behind it all. Look, if you want to actually understand the tech shaping our world, subscribe for more weekly breakdowns. Like to help others find this, and share it with anyone who's curious about AI. Let's get into it. Meet the firstborn of neural networks, the Feedforward Neural Network, or MLP, which stands for Multi-Layer Perceptron. Think of it like a one-way tunnel. You feed data in at one end, it passes through layers of logic, and an answer pops out on the other side. How it works is simple. Input flows in, passes through hidden layers with weights and activations, then boom, output. No feedback, no memory, just forward motion. It's like that student who memorizes every formula but never questions why they work. Ask them to think outside the box, they freeze up. These networks are great at basic language modeling, speech recognition, and structured data. But anything dynamic, like understanding time or context, they can't handle it. MLPs are the foundation of deep learning, but by themselves, they're blind to time and context. They're the calculator of networks, precise, fast, but rigid. Here's a real-world example. Your bank using MLPs to detect credit card fraud by analyzing spending patterns. Spotify's early recommendation system that suggested songs just based on your listening history. Email spam filters that learned which words meant junk. Even the first version of Google's search ranking algorithm used these simple networks. Next up, convolutional neural networks. The reason your phone knows where your face is. CNNs specialize in processing visual data, especially images. Here's how they work. They scan images using small filters or grids. These filters detect local features like edges, textures, and shapes. Then deeper layers combine these features into full understanding, like identifying a cat. The genius part? They reduced computation by analyzing parts hierarchically instead of the whole image at once. Think of it like a face recognition app. It doesn't see your whole face. It sees your eyes, nose, cheekbones separately, then combines them to recognize you. CNNs excel at image classification, facial recognition, and medical scans. But sequences or time-based data? Not their strength. CNNs are the visual thinkers of AI. If Feedforward was a calculator, CNN is your camera lens with laser focus. Instagram filters that add dog ears? CNN. Tesla detecting stop signs? CNN. Doctors finding tumors in X-rays? CNN. Your phone organizing photos by faces? CNN again. Pinterest suggesting similar images? CNN. Even agricultural drones identifying crops diseases from above? All powered by CNNs. Recurrent neural networks brought something revolutionary: memory. They remember what happened before and let that memory affect what comes next. As input flows, the network updates what we call a hidden state, basically short-term memory. This hidden state captures context from previous steps, and that memory influences the next output. It creates a feedback loop for understanding sequences. Imagine reading a sentence word by word, letting each word shape how you understand the next one. That's exactly what RNNs do. They're fantastic at language modeling, stock predictions, and speech recognition. The challenge? Long-term memory. They struggle to remember information from many steps ago. Think of them as having limited attention spans, great with recent context, but earlier details fade away. Siri's early speech recognition that processed your voice word by word. Netflix predicting what episode you'll watch next based on your viewing sequence. Stock trading bots that analyze price movements over time. Your phone's predictive text keyword that suggests the next word based on what you just typed. Even music apps that create playlists based on your listening patterns. Classic RNN territory. LSTM stands for long short-term memory. Think of it as the student who takes detailed notes. Unlike RNNs, LSTMs were designed to solve the memory problem. They can decide what to remember, what to forget, and when to write something down. LSTMs use these things called gates. A forget gate decides what information to discard. An input gate decides what new info to store. And an output gate decides what to send to the next step. It maintains what's called a cell state, internal memory that carries long-term information across time. It's like your brain deciding what to store in short-term versus long-term memory. Okay, I need to remember this phone number, but not the random ad I just saw. LSTMs excel at time series data, translation, and music generation. The trade-off? They're slower to train and computationally heavier. They're methodical, they preserve context, and they don't forget what you said 3 paragraphs ago. LSTMs brought sustained memory to AI, crucial for understanding complex sequences. Google Translate before Transformers took over. LSTMs remember context across entire paragraphs. Amazon's demand forecasting that predicts what you'll buy next month based on patterns from last year. The AI that composes music for video games, remembering themes and motifs throughout. Weather prediction models that track storm patterns over days. Your smartwatch tracking your heart rhythm and alerting you to irregularities. Even handwriting recognition on tablets. LSTM watching for patterns in your strokes. Then came the Transformer, and everything changed. Transformers introduced the attention mechanism. They don't process info one word at a time, they read everything at once and figure out what matters most. Instead of reading step by step like RNNs, Transformers read the entire input sequence at once. They apply something called self-attention to figure out which parts relate to each other. This gives them global context, not just sequential memory. Imagine reading a book by jumping to every paragraph instantly and understanding the entire plot in seconds. That's Transformer efficiency. They powered ChatGPT, modern Google Translate, and BERT. The challenge? They require massive amounts of data and are expensive to train. Transformers are the powerhouses of neural networks. They don't just learn, they understand language like humans do, with context, nuance, and connections. They're analyzing the entire meaning structure, not just predicting the next word. ChatGPT writing your emails? Transformer. Google translating 100+ languages instantly? Transformer. GitHub Copilot finishing your code? Transformer. That AI that passed the bar exam? Transformer. Grammarly suggesting better ways to phrase your sentences? Transformer. Even AI-powered search engines that actually understand your questions? All Transformers. Generative adversarial networks revolutionize creative AI. They're built on a brilliant concept. Pit 2 neural networks against each other. One generates data, one spots fakes. The generator creates fake data like synthetic face images. The discriminator tries to spot if it's fake or real. Over many rounds, both improve. The result? Synthetic data that becomes incredibly realistic. It's like a forger and an art expert in a constant competition. Each time the expert catches a forgery, the artist refines their technique. GANs excel at deepfakes, art generation, and voice cloning. The concerns? They can produce unrealistic outputs, carry biases, and raise ethical questions. GANs aren't just learners, they're creators. They generate entirely new content that never existed before. Those viral celebrity deepfakes on social media? GAN. NVIDIA's AI that turns sketches into photorealistic landscapes? GAN. Apps that age your photos or change your appearance? GAN. Fashion brands using AI to design new clothing lines? GAN. Movie studios using GANs to create realistic CGI characters. Even medical researchers using GANs to generate synthetic patient data for training. Protecting privacy while advancing research. So, why learn all this? Because each neural network is built for a different kind of intelligence. Feedforward is the calculator. CNN is the image detective. RNN is the sequence processor. LSTM is the long-term memory keeper. Transformer is the context master. And GAN is the creative generator. Understanding the architectures means you'll know why ChatGPT sometimes hallucinates, how Instagram knows what you want to see, and which AI to use for your next project. Using transformers for simple math? That's computational overkill. Trying to make CNNs understand conversation? Wrong tool for the job. Expecting RNNs to remember context from 50 messages ago? Beyond their capability. Training GANs without sufficient data? You'll get distorted results. The key is matching the architecture to the problem. Think of AI as a toolbox, not a hammer. Don't use a CNN for a sentence. Don't throw a transformer at a simple table of numbers. Ask yourself, what kind of data is this? Does it need memory, context, creativity? Am I feeding the right brain for the job? Because using AI without understanding is like flying a plane without knowing where the cockpit is. But when you do understand, you're not just a coder anymore. You're an AI architect. If this video helped you understand the world of AI neural networks, give it a like, subscribe, and hit the bell. It really means a lot. Thanks for watching, and I'll see you in the next one.